y to the fourth plus x cubed plus 2y equals 5. And we want to find the rate of change of y with respect to x. The way we solve these problems for starters is to take the derivative of both sides. And actually, I should be a little bit more careful because it's not just the derivative, it's the derivative where we treat x as the variable and we're treating y as a function of x. And that's important because it means you're going to end up using the chain rule in a bunch of spots. So on the left we have the derivative with respect to x of y to the fourth plus x cubed plus 2y. And on the right, the derivative of 5. Now the derivative of y to the fourth, since this variable and this variable don't match up, it's not just 4y cubed. It's 4y cubed times dy dx. So again, that's just the chain rule at work. Then the derivative of x cubed is 3x squared. And the derivative of 2y is 2 times dy dx. Then finally the derivative of 5 is just 0. So now we have a new equation that has some x's in it, and some y's, and some dy dx's. And since our goal is to find dy dx, step 2 is going to be to isolate dy dx. So you just want to treat it like a whole separate variable and solve this equation for that. So let's start by taking all of the non-dy dx terms and moving them over to the other side. So from here, if I subtract 3x squared on both sides, then you end up with the equation 4y cubed dy dx plus 2 dy dx is equal to negative 3x squared. And now, since all the terms on the left have a factor of dy dx, we can just factor that out, which leaves you with 4y cubed plus 2. And finally, now on the left, I have dy dx times some coefficient here, so we'll just divide both sides by that new coefficient. Divide by 4y cubed plus 2 here, and 4y cubed plus 2 here. And so the final answer is that dy dx is negative 3x squared divided by 4y cubed plus 2. Notice that your answer has x's and y's in it, and that's typical. Most answers to implicit differentiation problems will have to be functions both of x and y.